Welcome back. We now look at derivatives of quotients. The derivative of a quotient is not the quotient of the derivatives. In other words, if I am taking the derivative of a fraction t over b, where t and b are functions, then the derivative isn't the same as the derivative of t divided by the derivative of b. So the derivative of a quotient is not the same as the quotient of the derivatives. Let's look at an example to see why this equation doesn't hold. So let's take t of x to be x to the 9 and b of x to be x to the 5. So t is the top function and b is the bottom function. So then the quotient t over b would be simply x to the 9 over x to the 5, but x to the 9 divided by x to the 5 is x to the 9 minus 5, which is x to the 4. So we see that the quotient t over b is just x to the 4, and so the derivative of the quotient t over b is 4x cubed. Now let's look at the ratio of the derivatives of the top and bottom. So what's the derivative of the top and the bottom? The derivative of the top would be 9x to the 8, and the derivative of the bottom would be 5x to the 4. So if I take the ratio of the derivatives, that would be this, which is 9/5 x to the 4. So we see that the ratio of the derivatives of the top and the bottom is 9/5 x to the 4, and the derivative of this quotient t over b is 4x cubed. So they are not the same. So the derivative of this quotient is not the same as the quotient of the derivatives of the top and the bottom. So then what should be the derivative of a quotient? Well, here is the quotient rule. If t and b are differentiable functions and their quotient is f of x, so f of x is t divided by b, then the derivative of this quotient would be equal to this fraction where the denominator is the square of the bottom function b, and in the numerator we have the the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom. So that's the quotient rule. And in short, we can rewrite this as this. The derivative of t over b is equal to t prime b minus tb prime divided by b squared. So this is the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom divided by the square of the bottom. Here is my first example. Let's say f of x is 5x divided by x cubed plus 4. What we want to do is find the derivative by using the quotient rule. So by the quotient rule, then we know that the derivative of f would be the following fraction, where the denominator is the square of the denominator here, and then the numerator what we have is the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom. So once again, in the numerator what I have is the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom. So now this would be derivative of 5x is just 5, so I get 5x cubed plus 4 minus 5x, and the derivative here would be 3x squared. So now we just multiply out in the numerator and we simplify. So if we do that, we get 5x cubed plus 20 minus 15x cubed, and so we get 20 minus 10x cubed divided by x cubed plus 4 squared. In the numerator, notice that I can factor out a 10. In fact, I'm factoring out a negative 10, and if I do that, if I factor out negative 10, then I get x cubed minus 2 divided by x cubed plus 4 squared. So that's the derivative of this function, which we found by using the quotient rule. One thing I would like you to point out here is that there is no reason to multiply out the denominator. So multiplying out in the denominator doesn't simplify the expression. So in the denominator, I wouldn't multiply out here. And later on, you'll see that that writing the derivative in this form is the right thing to do. You shouldn't be expanding the denominator, the square in the denominator. Okay, so let's find the derivative of the ratio 2 plus x cubed over x cubed. And we're going to find the derivative two different ways. In the first way, first we're going to find the derivative by using the quotient rule, and then we will find the derivative without using the quotient rule. So let's use the quotient rule. The derivative of this quotient would be equal to the fraction where the numerator is the derivative of the top times the bottom minus the top multiplied by the derivative of the bottom divided by the square of the bottom. So now we need to just calculate these two derivatives, and then we simplify the expression in the numerator and in the denominator. So in the numerator, what we get is 3x squared here multiplied by x cubed, and then here we get 3x squared as well. So now here we would be getting 3x to the 5. Here we would get negative 6x squared and negative 3x to the 5. So then 3x to the 5 cancels out. We get negative 6 divided by x to the 4. Okay, so we calculated the derivative here by using the quotient rule, and we got negative 6 over x to the 4. So now let's find the derivative without using the quotient rule. So what we do is we just do some algebra here first. That is, this fraction, we're going to express this fraction as well, we're going to break this fraction into two fractions. So basically we're going to write this as 2 over x cubed plus x cubed over x cubed. So if I do that, I get this. Now x cubed over x cubed is just 1, and 2 over x cubed is 2 times x to the negative 3. So now if I take the derivative, by the power rule here, I get so 2 times negative 3 x to the negative 4, and the derivative of 1 is 0. So then we get negative 6 here, x to the negative 4, but x to the negative 4 can be written as 1 over x to the 4. So again, we get negative 6 over x to the 4, which is the same answer as we obtained in the previous slide when we used the quotient rule. Generally speaking, if one can find the derivative without using the product rule or the quotient rule, that might be the better way of finding the derivative. Okay, so let's do another exercise here. We want to find and simplify the following derivative. So here we have the function f of x, which is equal to e to the x over x squared plus 3. So by using the quotient rule, we see that we get the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom divided by the square of the bottom. And derivative of e to the x is just e to the x. Derivative of x squared plus 3 would be 2x. So what we get is the following. So here in the numerator, we're going to factor out e to the x, and if we do that, we get e to the x times x squared minus 2x plus 3. So we get e to the x times x squared minus 2x plus 3 divided by x squared plus 3 squared. Okay, so that's the derivative of this function e to the x over x squared plus 3. All right, let's now look at this function f of x is equal to ln of x divided by 8 plus ln of x. And again, by using the quotient rule, we have to square the bottom, and then in the numerator we get the derivative of the top multiplied by the bottom minus the top multiplied by the derivative of the bottom. Now the derivative of ln of x we know is 1 over x, and the derivative of 8 plus ln of x would be 0 plus 1 over x, so I get 1 over x here as well. So you get 1 over x, 8 times 8 plus ln x minus ln x times 1 over x. So notice that I have 1 over x times ln x here, and that's going to cancel out this term, so I basically get 8 over x. And to simplify that, I'm also going to multiply by x over x. Okay, so let's forget about what I just said. That we're just going to multiply by x over x. So that way we get rid of this denominators here, x's. So when you multiply x with this, you cancel out the 1 over x, and when you multiply x with here, you cancel out the 1 over x here. So you get 8 plus ln of x minus ln of x. Here you get x times this guy, and then ln of x cancels out. You get 8 over x times 8 plus ln x squared. Okay, so that's the derivative of f. So again, instead of multiplying by x over x, like I said, we could have we could see that 1 over x ln x cancels out this guy, so you're left with 8 over x here. But then 8 over x, that x we can put in the denominator. So this is 8 over x, and then 8 plus ln x squared. Okay, so that's all I have to I want to say about the quotient rule and applying the quotient rule to find derivatives of functions that are quotients of two other functions. Okay, so let me stop here, and I hope to see you in the next video.